it will only be used on those really demanding, challenging applications, potentially in oil and gas, in naval occasionally, and certainly the chemical process industry, where you need that really high level of strength and corrosion resistant and a wide temperature operating range.
In today's technical corner, we're looking at a very special material you might never have heard about, or maybe even come across. But luckily enough, Rodney from Langley Alloy is going to tell us all about it. This is alloy 725. Now, what is it?
It is a pretty rare alloy. It's also a pretty expensive alloy, but there's a reason for that. It is providing pretty high levels of performance. You take the corrosion resistance of something like Inconel 625, which is widely used in aerospace and chemical processing, and then you take the strength of 718, which again is widely used in oil and gas and aerospace, and you marry those two things together and you end up with 725. So within the alloys that we focus in, it's pretty spectacular in terms of that combination of performance.
Yeah, absolutely. It's so expensive. This isn't 725. You couldn't trust us with bringing it into the studio, unfortunately. Maybe trust yourself on the M6 on it. But what I find fascinating is it's actually, from a design engineer's point of view, it's almost like the perfect material.
It certainly achieves, levels of performance that are right up there, and I guess that probably defines why it's not so widely used. It will only be used on those really demanding, challenging applications, potentially in oil and gas, in naval occasionally, and certainly the chemical process industry, where you need that really high level of strength and corrosion resistant and a wide temperature operating range. And to be honest, it's difficult to find another alloy that would tick all of those boxes at such a level.
Absolutely. So it's it's a cut above everything else, but as with all things, there are trade-offs.
Yep.
The machinability and the cost definitely suffer a little bit. So when you talk about these difficult environments, can you talk a little bit more about exactly where these components would go and what they look like?
To be honest, when it comes to the choice of the alloy, that's largely informed by the end use, the application. So you are thinking of potentially a bit of process equipment that's operating at 500, 600, 700, 800 degrees centigrade, but where the environment is very aggressive, polluted environment or acidified. But then the component itself needs a high level of strength. So that could be fasteners, but it could also be smaller machined components. It tends to be one of those products which is ordered for a specific project or end use in mind, not something that's just picked up and used on an everyday basis. Yeah, we carry it in stock in sort of smaller diameters where you can machine those sort of ancillary components, fixings and fasteners from. But for the larger components, because it's so expensive really, they'll typically be supplied by somebody else as a forge component. So we're there to help complete a project.
And do some customers that you found before they found Langley alloys, do you find that they struggle to source this themselves?
I think it's one of those things that will not come up that often, and quite possibly they're either going to go to an existing supplier like ourselves and say help, or they may just rely on Google, in which case hopefully they'll find us reasonably quickly as well. But either way, we'll have that conversation and we'll say, sure, we've got it available ex stock, we can sort you out.
Yeah, absolutely. And for those design engineers who are looking at maybe doing these difficult components in harsh environments, what should they know about stock lead times? If it's quite a rare material, it might be quite hard to get hold of.
For sure. So it's a difficult product to manufacture in the first instance. To achieve that high level of strength, you have to change the composition. You tweak the recipe slightly, which creates its own challenges for the manufacturers. It has an additional heat treatment process, which again adds additional time and additional cost. And if we were to order this from our supply partner, we wouldn't expect to see it for at least 12, if not 18 months. So that's the reason why we carry stock, in case somebody needs it and they can't afford to wait for 18 months.
You mentioned the recipe earlier that makes the material. What exactly about the recipe makes it so special?
It's a combination of what it's made from and how it's made. So it's a nickel-based alloy. 50 to 60% of its content is nickel, and nickel's an expensive constituent. So that's part of the story, but that helps to provide a really wide temperature operating range and good performance. You're then alloying it with other relatively expensive materials like molybdenum and titanium and chromium. So you put all of that together and you get something with, really, really good corrosion resistance. That's half the story. To get the strength, you then alloy it with very small precise quantities of niobium, titanium, maybe a bit of aluminium as well. And all of those things together will form really fine precipitates in the metal, which come out during a secondary heat treatment. And those little precipitates help to strengthen the alloy. They pin the grain boundaries. That's the metallurgical explanation within it.
Okay, we have to spend a lot of time to explain that, maybe.
Yeah, exactly. But that's where the strength comes from. So you have a very precise recipe, you have that additional processing, you have that metallurgical phenomena of precipitation strengthening going on, and that gives you that combination of excellent corrosion and high strength together, which is difficult to achieve otherwise.
And I guess that when customers are asking for material this specialist, they expect it to be tested, to be validated, to make sure they're getting what they're paying for.
Not many people will manufacture it in the first place. It's not straightforward to manufacture. And almost by definition, it's only going to be used in mission critical projects. So it's one of those things that we source very carefully. And I guess our customers will do the same when they come to us.
So that's alloy 725. It's got some fantastic chemical properties, capable of doing lots of different applications, and you can get it here from Langley Alloys.